10.4.3 Classifying Conic Sections. This part is a summary of our conics. This first equation is a reminder of a circle whose center is at HK, and then obviously A and B are equal to each other, so it is just the radius squared. A parabola can be in the form y minus k squared or x minus h squared, depending on whether or not the parabola opens up or down or left or right. Ellipses can elongate horizontally or vertically. In this situation, A is always greater than B and B is always greater than 0. Hyperbolas, either A or B can be larger or they can be equal. The difference here is there is a subtraction sign in the middle. So that's a review of our equations that we've gone over so far this chapter. If the graph of ax squared plus cy squared plus dx plus ey plus f equals 0 is a conic, then the type of conic can be determined as followed. So we don't actually need to have it in our standard form equations. If a equals c, then we have a circle. If a times c equals 0, then we have a parabola. If a times c is greater than 0, it's an ellipse. And if a times c is less than 0, it's a hyperbola. So we really just have to identify the coefficients for x squared terms and our y squared terms to determine what type of conic section we have. Classify the conic given by 2x squared plus y squared minus 4x minus 4 equals 0. So our a value is 2. Our c value is 1. 2 times 1 equals 2, which is greater than 0. So we have an ellipse. 4x squared minus 9y squared plus 32x minus 144y minus 548 equals 0. A is 4. C is negative 9. 4 times negative 9 is negative 36, which is less than 0. And therefore, we have a hyperbola. This one, we have a 2x squared and a 2y squared. So A is 2, C is 2. Since 2 is equal to 2, we don't need to worry about the product. This is a circle. 6y squared plus 3x plus 2y plus 1. A is 0, C is 6, 0 times 6 equals 0, so we have a parabola, which of course, if you only see one squared term, you should know it's a parabola. That is the end of chapter 10.